Straight back again, students. Today, got section 4.4, unstable nuclei and radioactive decay. This you have no notes from Hummer, so make sure you get really good notes on this one. And then we got objectives. You need to be able to explain the relationship between unstable nuclei and radioactive decay and characterize alpha, beta, and gamma radiation in terms of mass and charge. A little review, vocab, element, definition for an element. I'm sure you know that one. Wow, lots of new vocab you're going to get as we go through here. I'm sure you have all those definitions in your notes. Unstable atoms emit radiation to gain stability, our main idea. Oh, radioactivity. Radioactivity happens as nuclear reactions go on, changing one element into another element. Late 1890s, some scientists noticed certain substances spontaneously emitted radiation. They called that radioactivity. And the rays in the particles, substances emitted, are called radiation. So radioactivity is the process, radiation is what's being emitted. And any reaction that's going on to emit this radiation is called a nuclear reaction. And unstable nuclei lose energy by emitting radiation in a process called radioactive decay. So, 3, radioactive decay, radioactivity, radiation. Different things talking about the same process. And as radioactive decay happens, they form stable, non-radioactive elements. We got a few different kinds of radiation. Alpha radiation, made up of positively charged particles called alpha particles. And each alpha particle contains 2 protons and 2 neutrons and has a 2+ charge. So we can have nuclear equations. Here's one showing the radioactive decay of radium-226 into radon-222. And it emits this alpha particle. It's equivalent to a helium-4 nucleus, so we use this notation or this notation. I prefer this helium notation. It tells us a little more about it than just the Greek letter alpha there. And mass is conserved. If we look at it and write the 4,2He up here, see 226 is 222 plus 4. 88 is 86 plus 2. So mass is conserved. Beta radiation emits beta particles. Beta particle, an electron, -1 charge. So there we can use the symbol E with a 0 and a -1. And we see 14 plus 14 here. 14 equals 14 plus 0. 6 equals 7 minus 1. What happens in beta decay? A neutron in the nucleus breaks down into a proton and an electron, and the electron is emitted at high rates of speed. The proton stays. Yeah, that's why our atomic number here is going up from 6 to 7. And a little chart here showing radioactive decay. Got a radioactive source, shoots through here. Got a positive plate, a negative plate. The beta particles bend up this way because they're attracted to the positive plate. The alpha particles bend down this way, being attracted to the negative plate. Gamma rays, which have no charge, go straight through. And you see our 3 Greek symbols there also. Yeah. Gamma rays, which we just seen on there, just high radiation energy, no mass, neutral. Frequently accompany alpha and beta radiation. So just here we got some uranium breaking down to thorium and an alpha particle, and we get some gamma rays off. And this is where most of the energy loss during radioactive decay happens, just from gamma rays. It's an important little table, contains a lot of information about the alpha particle, the beta particle, and the gamma particle. So, gamma rays are massless. The emission of gamma rays does not result in the formation of new elements or new atoms. Alpha and beta particles make new atoms. And atoms that contain too many or too few neutrons are unstable, lose energy to form a stable nucleus. So, too many or too few neutrons is what makes them radioactive. So we have few radioactive isotopes existing in nature because most have already decayed to stable forms. So, you should find some more information in the book that might be useful to write down. So we go through some problems. We'll talk about a lot of this. But this one you haven't seen yet. Hummer notes. Make sure got good notes. And a couple quick review questions. Reaction changes one element to another in the nucleus of an atom is called what? That's a nuclear reaction. And why are radioactive elements rare? Because they've already decayed. So that takes care of 4.4. Takes care of chapter 4. With this, it means we should be getting reasonably close to time for a quiz. I'm sure you're ready for that. That's all for now.